So this is the second question that you sent me, Maddie, that it says CBS News New York Times poll found that 329 out of 763 randomly selected adults said they would travel to outer space in their lifetime given the chance. That's our p-hat, which I converted to a decimal for simplicity's sake. Estimate the true proportion of adults who would like to travel to outer space with 92% accuracy and round to 3 decimal places. So the formula you've learned to use for a confidence interval to estimate a population proportion is the one that you see written here. P-hat plus or minus your critical value. Your book may use a slightly different notation for that. It might use Z of alpha over 2. Means the same thing. How many standard deviations out in the normal curve do you need to go to capture the middle 92%? And then that's multiplied by what we call the standard error of our proportion, and that's the square root of our p-hat times 1 minus p-hat all over n. So what we need to do is we need to enter all of the values necessary for this calculation. So our p-hat, we said, was the 329 out of 763. Our z-star we're going to need to get in the very same way that we did in the previous video that I made for you. We can either go to our table and look for the z-score, or we can do the inverse norm. But first, let's visualize this. This is a confidence interval. It is intended to capture the middle 92% of this curve, which leaves out 8%, half of which needs to go in each of these tails. The last one was a right-tailed. A confidence interval is always a two-tailed. So we basically got 4% in each tail. So what we can do is we can do inverse norm of 0.04, and that'll give us the lower critical value. Or we can go to our table body and look for as close to 0.0400 as we can get, and find the lower critical value. What we'll find is this lower critical value has a z-score of negative 1.75. So that means that this upper critical value is the opposite, because they're the same distance from the center because of the fact that we're talking about the middle 92%. Therefore, that's our critical value, 1.75, positive and negative. And then we need to multiply that by our standard error, which is our p-hat, about 0.43, times 1 minus p-hat, which would be 0.57, over our sample size, which is 763. And then we just compute that. We type 329 over 763 minus 1.75 times the square root of the 0.43 times 0.57 over 763, and then we do the plus as well. There is a way, Maddie, that this can be done on your graphing calculator, and so I want to make sure I show you that method as well. If underneath your test menu, you will find all sorts of tests and confidence intervals. If you go to Stat, Tests, over to the right, and you arrow down a ways to option A, you see something called a 1 prop Z interval, which is what we are dealing with here. So you select option A, 1 prop Z interval, and it asks you for the value of X, N, and the confidence level. And so our X is 329, our N is 763, and our confidence level is 92%, so we enter 0.92, arrow down to calculate, and hit enter on calculate. And it gives us the very same interval that we got by calculating it by hand on the previous page. So we can basically say that we are 92% confident that the true proportion of adults who would like to travel to outer space is somewhere between 0.3998 and 0.4626, or somewhere between 39.98% and 46.26%. Hope that helps. Let me know if you have other questions.